All right, everybody. Welcome. We'll give just a couple seconds for folks to join. Everybody trickling in, and then we will go right through our slides. So just maybe 10 more seconds. All right, folks are still coming in. All right, I think we'll get started since we have a great group here, lots to discuss. So I don't want to hold us up. Welcome, everybody, to our industry partner webinar, sponsored by Sirona today. And the topic is unification as the foundation for profitability and meaningful AI deployment. Just a couple logistical things before we get into the panel. We do offer SIIM imaging informatics professional credits for the webinar. You do have to stay on for at least 45 minutes to be eligible and then complete the survey at the end of the webinar. And the credits will be in your MySIM account within 48 hours from the completion of the webinar. Just make sure that you note what types of credits you would like to receive in your MySIM account. That has to be done before this webinar closes. If for some reason you were not able to do so, just email us at info@sim.org and we will fix that for you. For folks that need their SIP credit transfer to Abby, we do offer that quarterly. Make sure that you put in your Abby ID as well as your birthday in your MySIM account, and we will make that happen for you. We will try to leave time for Q&A with this great panel, at least a couple minutes before we close the webinar. So make sure that you put any questions you have in the Q&A at the bottom of your Zoom control panel. And with that, I am going to turn it over to Andrew Colbert, the VP of Marketing for Sirona, to make the introductions of today's wonderful speakers. Andrew?
Awesome. Hi, everyone, and welcome. And again, thank you for joining us for today's webinar, Unification as the Foundation for Profitability and Meaningful AI Deployment. As Anna said, I'm Andrew Colbert. I'm part of the Sirona team, and I will be moderating today's discussion. The goal of our conversation is to look honestly at where radiology is today, particularly at the intersection of workflow, infrastructure, and AI, and to explore what it actually takes to move forward in a sustainable way. We all know radiology is under real pressure. Volumes continue to rise, margins are tight, IT environments are more complex than ever, and AI, while incredibly promising, has often delivered more fragmentation than impact. Today's discussion is about why that is and what foundational changes are required before AI can truly deliver clinical, operational, and financial value. Before we begin, let me briefly introduce today's panel. Dr. Curt Langlotz is a professor of radiology, medicine, and biomedical data science at Stanford University. He has been a leading voice in radiology AI for decades, helping to shape how we think about workflow, data, and the role of artificial intelligence in clinical practice. Ken Kaufman is the CEO of Sirona and brings decades of experience leading large-scale radiology IT organizations. He has previously led the international business at McKesson, and he has worked closely with health systems navigating the operational and infrastructure challenges that define modern imaging. Dr. Alex Kagan is site chair of Mount Sinai West in Morningside. He is a professor of radiology, artificial intelligence, and human health, a practicing radiologist, an experienced entrepreneur in radiology workflow technology. He will be offering a frontline perspective on how today's challenges manifest in daily clinical practice and his vision on how he sees the practice of radiology evolving. Dr. Mark Longo is the Chief Technology and Innovation Officer at Sirona. He earned his PhD from Stanford and built cloud-native platforms that unify data, workflow, and AI in radiology. He previously led application support at McKesson for solutions deployed across nearly half of large US hospitals. And for context, Sirona is a cloud-native radiology company focused on unifying the radiologist workflow, bringing images, data, reporting, and AI into a simple integrated environment. Rather than adding more point solutions, the company's thesis is that unification at the infrastructure level is what ultimately enables efficiency, scalability, reliability, and meaningful AI adoption, both for the radiologist at the and for the practice at the bottom line. With that framing in mind, let's start at the beginning by looking at how radiology workflow and the radiologist desktop have evolved to where they are today. Dr. Langlotz, I'd like to start with you. Can you speak a little bit about how radiology IT and the radiology workflow has evolved over the past 20 or 30 years to present day?
Yes, thank you, Andrew. And it's a pleasure to be here with all of you and with this esteemed panel today. I'm looking forward to the conversation. Yeah, so let's talk about the Jurassic era long ago. So originally, PACS systems were so complicated because of the large data sizes for their time. We needed separate networks. We had our own networks. We had to have our own hardware. We had to have our own monitors. And so PACS have evolved as separate systems. Likewise, speech recognition, even when it was first came available 25 years ago or so, we needed special processors on the PCs in the reading room to manage the real-time speech recognition. Then we had separate applications often for work lists. We had advanced image viewers that came online that we needed to work with separately. And of course, now we're seeing more artificial intelligence tools, which again, often are separate. So as a result, we have now, yes, we have off-the-shelf hardware, we have off-the-shelf monitors, but on our desktop, we often have all of these disparate tools from different vendors that have grown up separately in different segments of the industry. And as a result, our experience is disjointed. And I think that's because, yes, there are attempts to integrate these tools both on the front end and the back end. So place the windows in the right way, maybe have them talk to each other in some situations. But I'll tell you, from my personal experience, I've had experiences where I take an exam off the work list, I interpret the exam, I dictate it into the speech recognition, I sign it, and then I go back to the work list, and it's still sitting there right at the top of the work list because it takes a while through the back-end integration for all that communication to happen and for it to clear. So that's really not the kind of experience that we want to have. And of course, in the last several years, we now have this wonderful cloud technology. So we have cloud native image viewing, we have cloud native speech, we have obviously AI can run in the cloud, we have infinite compute capacity in the cloud. So we have this opportunity now to have a unified system that's built to make for a beneficial experience for the radiologist that integrates PACS and speech and work lists and advanced viewing and AI all in one. And I think that's really going to be an important step forward.
Interesting. So in this environment, can you speak a little bit more about what some of the biggest pain points that are felt by radiologists and where the biggest opportunities are for technology to help?
Yeah, well, one I hear about a lot are display protocols. The system doesn't know where to put anything. I end up spending a lot of time moving stuff around. That's a big one. Speech recognition, I think, in many cases, we are using user interfaces that were designed a very long time ago. Some of the only customization tools we have are point and click macros, which are nice. I mean, they're better than starting with a blank page, but it's really not as sophisticated a functionality as we'd like to have. And the work lists, we have, yes, some sorting, some searching. Increasingly, we're getting some AI to prioritize the work lists, but again, not the functionality that we'd like. So a lot of those pain points, I think, are important.
Thank you, Dr. Langlotz. So it seems clear that there's a lot of opportunity in infrastructure ultimately, and I'd want to transition the conversation a little bit to Ken Kaufman, the CEO of Sirona, and spend a few minutes understanding from your experience, Mr. Kaufman, leading large radiology IT organizations, what's fundamentally broken with today's infrastructure?
Sure. First of all, Kurt, thank you for the Jurassic period conversation. Now I feel really old when talking to my kids about this. I'm never going to get past that. But the golden age for PACS was actually 2005 to 2007. That's where we reached the point where 70% of the radiology readers actually were on a digital PACS of sorts. And the question about infrastructure really wasn't even thought about then. I mean, really what happened was what Kurt was saying. We had giant studies. So we went from, you know, 40 slice CTs to 400 or 4,000 slice CTs. And we had to very quickly go ahead and get people onto digital systems to go ahead and read. And the great part about that was that everybody needed them. So it was a great time to go ahead and be in that business. But I don't think any of us thought 20 years ago that the products that we were installing were infrastructure based or going to be still primarily used today. And the majority of those systems are still installed today. So just to give you a little color on the Jurassic period that Kurt was talking about, YouTube was launched actually in 2005. In 2005, 75% of Amazon's revenue was selling books. Um, and broadband back then was 1 megabit to 3 megabit. So this concept of infrastructure really wasn't there. I mean, this was 7 years before Netflix hit. So we were solving a problem, and the problem was a very, very difficult problem. Radiology data is 70% of the data in healthcare. It was coming very, very fast to radiologists, and they needed to go ahead and read them. And as a result, we have 6 to 7,000 PAC systems that are installed in basements of hospitals across the US. Their average age is over 20 years. And even in an area like San Diego, where I am, where you have a pretty homogeneous environment, you have a Sharp Healthcare, which has 8 hospitals, and Scripps that has 7 hospitals, and UCSD and Kaiser. The ability to go ahead and just get an image from one to another is really burning a DVD and bringing it across. So we really have had a lack of innovation in radiology, and primarily the reason was or is because there really is no infrastructure. There's a bunch of point-to-point systems that are sitting in the basement of hospitals. And so $5.3 billion has been invested in diagnostic AI, and we have some great tools out there, a lot of FDA cleared algorithms. The problem is no way to reach the radiologist. What Kurt was just talking about is in the real world, the radiologists are still waiting for things to clear from a work list as opposed to go ahead and get meaningful help with AI.
That's really interesting. Can you talk a little bit about some of the broader business implications and what this means for those providing radiology services in this environment?
Yeah, it's really a crazy time in radiology, and Kurt could speak to this, but there's been a shortage of radiologists ever since people said, well, AI is going to come and we're going to eliminate the radiologist. And so this has really compounded the fact that we have few radiologists. It's a growing, again, percentage of data in healthcare. And what's happened here is 93% of the hospitals and imaging centers out there really have gone ahead and outsourced almost all of their IT. So there's Epic, Cerner, and Meditech on 93% of the beds in the US. And so what's that left us with is in the basement of all these hospitals is 500 terabytes to petabytes of data. And you have an IT staff that's pretty small now, and they're basically not looking at innovation. They don't have time for that. They have to make sure that the electrical's right, the AC is working, the disks are working. They have to go ahead and worry about virus and intrusion detection. And so there is a large investment in keeping these old systems alive. But the headwinds is that we're not really doing much to empower the radiologist to be a greater efficacy and to really go ahead and improve the quality of our reads. We're just pushing on our radiologists to do more and more. So, and this is even harder because we have a lot of consolidations coming on. And when organizations get together, they have disparate PAC systems. And to go ahead and bring these things together, there, as Kurt talked about, they are very antiquated. They're very old. People worry about them failing. People, almost all of them are several revisions behind because people don't want to break them. And 40% of the radiologists today are working on two systems. I mean, we're talking about innovation here, but yet 40% have to toggle between two systems. And in the teleradiology world, it's 80%. So 80% of radiologists who are reading studies, and there are millions and millions and millions of these, have to go ahead and constantly be moving across systems. So, the largest challenge here and the biggest headwind is this old technology and this old legacy environment. And so how can you really go ahead and improve, innovation and efficacy, um, if you're on these systems that we're really duct taping together? And I think that's probably one of the biggest challenges in front of all of us right now.
It's really interesting.
Andrew, can I
Yeah,
make
of course.
a couple of points? I just wanted to, Ken mentioned the workforce shortage, hugely important. You may have seen there was a story just this week about a practice that is 30 days or more behind in interpreting some important studies. And it's because in part, yes, perhaps some fear of AI, but I think a lot of it is just that our studies have gotten larger and the volumes have gone up because imaging is just such a compelling way to make a diagnosis, and the clinicians realize that, and so they order a lot. So we have more studies, we have bigger studies, and our training programs aren't producing any more radiologists. So that creates a shortage. And then I just also wanted to emphasize the point Ken made about these systems that are antiquated. Nowadays, a data migration project ends up being a data cleanup project. And that's a very different animal. It's a very complex. And so to find a way to bring your data into a system where you can really plug in the viewer that you want to use and not have to go through that is going to be a very important development.
Yeah, we can do a seminar on that, Curt, from
Yeah.
our experiences, because you just wrote a paper on it, and I recommend everybody read it because it's actually fascinating and something that people aren't aware of.
So I want to ask you one more question, Ken, and that's more on the vendor side of things. Ultimately, why is cloud migration so challenging and expensive? There's a lot of noise in the market, about cloud and cloud migration, but why is that the case? And why can't you just move code supporting on-premise solutions into the cloud?
Yeah, I mean, actually, if you walk down the aisles of RSNA, everybody's cloud-based, which is, amazing considering that, um, we're the only cloud vendor that I know of that has, millions of studies being read on it. So, cloud-based is a misnomer. So, you can go ahead and put old systems into the cloud and do it via virtual machines or Citrix or store images in the cloud. But that's really putting the lipstick on the problem. So just moving a problem where you have 7,000 devices, let's just say 7,000 on-prem systems, and you move them all to like virtual environments in the cloud. If you're a vendor, and I'll take McKesson as an example, we were a premium vendor, and we actually grew from 15 studies to 1,500 studies during this golden era of PACS, and it was a great, great system. But as you start to go ahead and have 20, 30 years of use of a product, upgrading that product becomes incredibly difficult. And it's difficult because of the nature of it is it's not modern cloud-based. So if you think of something like Salesforce, Salesforce is a multi-tenant product that allows customers to join, but every time you go ahead and roll out a Salesforce instance, you're not creating a completely new PAC system or a completely new CRM. You're basically rolling out a new feature, a new capability on Salesforce. So to just give you an idea of how hard this is, at Sirona, we just launched a couple of months ago our FDA cleared PET CT. So we're FDA to medical device. Now, to implement something like that in the old world of McKesson, even if they threw their systems into the cloud, you would have to go to those 1,500 customers, and you would have to go ahead and load all this new software, test it because every environment is different, and it would take years. With Sirona, when we launched it, you press a refresh of your web browser because there is no software on the workstation. Everything's cloud native. We're multi-tenant in the cloud. were unified in the cloud. And so the difference is very, very different. You could store images in the cloud, but that doesn't solve the fact that what you have is, as Curt described, Jurassic technologies that are basically very, very fragile. And they're put together really with what I would call PAX duct tape together. And PAX duct tape does not scale, and it doesn't provide you really any benefit. So going to the cloud is great, but it only really matters if you're going to the cloud in a way that basically benefits the cloud and the strengths of the cloud. And so we leverage AWS. We have the ability for a reader to be anywhere in the world and read on our system. And that actually is handled in a lot of ways through our relationship with AWS. That's very different than having a one-off system that is in a cloud that actually is ping-ponging across the US to go ahead and deliver images. So it's complex.
Interesting. Thank you, Ken. Dr. Langlotz, I'd like to transition back to you and sort of against this backdrop of economic pressure and infrastructure and demands on radiologists. Can you tell a little bit of the story of AI and how AI has developed into the workflow today and how we have ended up where we are?
Yes, sure. So yeah, you all remember back in the day, back in 2016, we had a lot of people saying AI is going to replace radiologists, and there was a lot of hype. And I know here in Silicon Valley, we saw a lot of money just being thrown at people who had a lot of AI expertise and say, go out and do something there. And I'm not sure that in some cases that developed into reasonable products and businesses, in other cases not. But I think that it's fair to say now, looking back, that the first wave of AI, as a result of some really dedicated people developing products in that area, is an emphasis on detection and triage. So if you look at the vast majority of AI products for radiology today, and by the way, more than 3/4 of FDA cleared AI products today are radiology focused products. So we are the tip of the spear. We are leading the way, however you want to call it. Radiology really is dominating the AI and medicine marketplace right now. But I think because of that FDA barrier, because there are difficulties in obtaining the right training data, and because of the ease at which you can bring detection and triage products through the FDA, we ended up with a lot of detection and triage products that reorder the work list, or products that help us find things, identify studies that have particular abnormalities. And if you think of that from the user's perspective, I would say radiologists, it's like, hey, that's kind of interesting. That's kind of cool. It might help me. But on the other hand, it might slow me down. If I have false positives that I've got to track down, I got to figure out, okay, this AI has alerted me to this thing. Is it real? Is it not real? So in our world where we are a piecework driven specialty and we're paid for what we do, if you're slowing us down, that's really a negative ROI, and you want to bring a positive ROI if you can. Many of these products really do help with the quality of care, but less so with the efficiency of care. And so that, I think, explains a lot of where we are, in that we have really nice set of products out there, but they're not adopted to the degree that I think people expected several years ago. We're, I would say, at the beginning of a second wave where we're starting to see products now that do have an ROI. So products that help us draft reports, products that provide the impression section of reports, and even some agentic so-called products, let's just say products of multiple AIs that are helping us handle workflow orchestration and tasks that are otherwise complex for radiologists. I think all of those things are going to bring savings. They're going to help radiologists focus on the part of radiology that we think is the most compelling and interesting to us. And so I think that's the world that we'll be seeing in the months and years ahead. A few months ago, I got very interested in the question of, well, how is this all going to affect radiology? There's a lot of rhetoric. There has been even back since 2016 about how AI is going to affect the practice of radiology. But I think now we have enough evidence in the literature for how AI might affect us in the future. I thought it'd be worth trying to quantify that. So I looked at all of the ways in which radiologists spend their time and tried to quantify that based on some published literature, and looked at all of the different types of AI algorithms and how they might affect the various aspects of radiology practice, and really tried to quantify that. And what we projected is that in about 5 years, we'll need about 1/3 less radiologist work or labor than we have today if some of these products come online. Like if you have a product that can draft your report for you, that's a significant efficiency. It can save time, can save work. If you have one of these agentic products that can help with notifying patients of critical findings or something of that nature, that can also help with efficiency. And so you might say, wow, if I'm a radiologist, I should worry, 33% less radiologists. But the countervailing trend is what we talked about earlier, the fact that the volumes just continue to grow. And so the volumes will grow even faster than that. And so it's like any other tool, like PACS itself, 20 years ago, that improved our efficiency greatly. No radiologists lost their job because we just had a lot more business and work to do, and we were able to do our work much more efficiently. So I think that's really going to be the effect of AI in the coming years. Is it will help us with the incredible amount of work that we now have to do, the kind of the burnout that we sometimes face. And so it's going to improve our efficiency and allow us to deal with the continued increase in the volume of work that we have to do.
Thank you, Dr. Langlotz. Dr. Kagan, I'd like to bring your voice into the conversation a little bit as well. As a practicing radiologist, what are some of the biggest challenges you're facing on a daily basis, and how do they really manifest themselves?
Well, again, thanks for hosting this, and it's great to hear Dr. Langlotz speak about that, and Ken as well. And I'll just add to what Dr. Langlotz said earlier. When we first started with some of these point solutions, we had to wait for the results, depending on how you integrated with. And what one of my mentors, David Mendelsohn, says is all about integrations, right? So if it's, it takes 20 minutes to get the result of the head bleed, some of our neuroradiologists are reading them in 10 minutes. So they actually had to go back and look at the result. And nowadays, things are a little better, but it just reminds me of that. So I would say, things that we deal with now and the challenges that we have now is inconsistency. So like inconsistent tools. We have at Mount Sinai, we have now 8 hospitals, multiple centers, and we're keep on merging, and every health system keeps growing and taking on new practices. And so, as Ken mentioned, in the basement, we have all these Jurassic period systems, and it takes a lot of time and a lot of budget cycles to harmonize those systems, so that you can have a more unified stack. And radiologists have grown accustomed to what they're used to, so that's a lot of switching for them. And that context switching between system causes cognitive load and burnout that Dr. Langlotz mentioned. And also deploying like AI uniformly without cloud native platform. We have some tools that we're able to use for some people, but we can't use it for others. And we also don't have access to various vendors. If you choose kind of point solutions, you're kind of stuck with that vendor until the next budget cycle, or until your evaluation cycle completes and you want to move on to a different product. Our IT system has become incredibly complex, and the more integrations we have creates more downtime risk, and different downtimes results in different teams trying to address the issue, and it involves different vendors. So a unified solution can hopefully decrease that. And our rad IT stack, whether it lives within radiology IT, as we kind of talked about earlier, or now if you're a big health system, it lives within the IT infrastructure. And we are now one of many priorities and as Ken mentioned, there's just not enough humans around to deal with just radiology issue. They have to deal with, the entire provider footprint of our health systems. And so, those are just some of the challenges we face now, and how, we need better solutions and better architecture to improve efficiency of the whole team.
Interesting. Thank you for that, Dr. Kagan. I'm curious, both from you, Dr. Kagan, and also from you, Dr. Langlotz, as we transition into sort of the power of this moving forward. What does meaningful AI actually require, and what is sort of the power? What does a system that is unified, leveraging sort of modern AI really start to unlock?
Yeah, exactly. You're seeing now another trend in AI that I think is very important is sometimes called multimodal. So we're dealing with multiple different data types, data sources. So we have the images, we have the reports, we have the EHR data, we have workflow data, and has systems that can manage both language and structured data and imaging data. And I think that's important because we want a system that can have a holistic patient understanding that can reason across the clinical history, the prior images, the prior reports, the current images, can understands display protocols, understands advanced imaging tools, understands the report, understands the workflow state that I'm in. And so when you can take your browser and point it at the cloud and are given a system that has all of those aspects, right? It has the integration between the image viewing, the clinical history, the reporting, and so forth. And you can have AI algorithms acting on that. That gives you a single platform, perhaps multiple AIs with different expertise that can help you with your workflow, can help you with your diagnosis and your reporting, all the tasks. So I think that's kind of that's where the leverage is in this. I think that's why I think that this multimodal trend is going to be very important, and this trend towards multiple AI agents that are cooperating and helping us with our work.
Yeah, I couldn't agree more with you. And you mentioned if we had kind of less cases to read. Well, maybe we don't want to really read normal chest X-rays at 2 in the morning. Maybe that's something we don't want to do. Something that we need to do and we can do that we haven't. I don't know if we've mentioned it today, but with an aging population and baby boomers, and as people live older and longer, we're going to have and the fact with new therapies, we're changing cancer management from a fatal disease to a chronic disease. And in order to manage those patients, they're going to get 15, 20, 30 scans over time. And treatments are going to make tumors shrink, make them grow. And so much of my time when I begin reading a case is reading the chart. And so summarizing the chart, summarizing the prior reports. I want to make sure, what did I say before? What did Curt say before? So, because he may say it a little differently, but if we have AI summaries of our prior reports, then we know, we can use that agentic workflow to contextualize everything for us in a smaller snippet, so that we can actually be better radiologists, be more informed of our patients, and then provide a better management plan, which is eventually what we do is help our providers manage these chronic diseases.
Thank you. Mark, I want to turn it to you from an engineering standpoint. What does that demand of the platform, and can you show us a little bit of how this starts to come together?
Yeah, absolutely. And it's funny because this is a great conversation, and I find it kind of heartening in a way, because I do think there are technical and design solutions to all the pain points that we're talking about. And I think those solutions look like it's going to be something cloud native, a unified data model and workflow, a system where you can build once and deploy everywhere to solve the deployment issues with AI, centralized and connected data, and AI that operates inside the workflow and isn't just an appendage, a potentially distracting appendage. And so, I think that's enough talking. I would like to show you some things. And so I was originally going to do a demo live. I ended up recording a demo as well, and I think the recording captures the story well. So let's start there. I do have a system up and running if we want to explore things live or go deeper. We absolutely can. But with that, let me share. Hey there, I'm Mark Longo. I am Chief Technology Innovation Officer at Sirona Medical, and I am going to demonstrate the power of unification for meaningful AI deployment. I will start with a flash tour of our platform. It is a cloud-native multi-tenant platform. That means it's built from the ground up to take advantage of native cloud infrastructure and data structures versus, say, taking a legacy app and putting it in a VM and hosting it on the cloud. You can access it from anywhere, anytime. This is just a shell on a Chrome browser, and it means we can release any functionality, including new AI, with a push of a button after doing our quality diligence, of course. So our platform is unified at 3 levels. One, which I just discussed, is architecturally. Everything lives in the cloud. It's built as a unified system. The other is that it's unified at the application layer. And so what I mean by that is we have our work list here in patient jacket, and we have our image viewer and our reporter. Let me hide these templates. All on one platform. And that's also true of our admin portal. I won't show that. And then the underlying database archive. This is our AI sandbox, and I will talk about that in a bit. But the beauty of being unified at the application layers, we know what's happening in each of these subsystems, so the system as a whole can respond accordingly. And just as a small example, let's see here, we have some segmentation models that can allow you to do something like segment the vertebrae and spine MRs, and we can do tie-ins from these segmentations, our knowledge about what anatomy is where here, to the reporter to do things like navigation. So navigate to whichever vertebra that you want. These segmentations, we're doing them for all sorts of different anatomies, and it sets up navigation features, it sets up error checking, it sets up volumetric analysis, or things like even better hanging protocols, because you can understand how much of each organ is visible in a series. So that's unification at the application layer. And then the last one is unification at the data layer. And I mean that both in the sense of that we have all the data that radiologists need to do their work, DICOM, HL7, but also that we've standardized those data to a common unified set of concepts via our custom ontology, which is basically high-powered knowledge graph with logical inference. And you can see that unification, standardization in action if we take a look at hanging protocols. So data come across from HL7 and DICOM. It can be pretty messy, and there are lots and lots of different ways to say the same thing. And what our ontology does is it goes through that soup of text and classifies things according to canonical concepts that our system can then act upon. So you can see, and this is demo data, so it doesn't have a lot of these dimensions, but it's classified each series, and then here's a study description, and you can see it in action. Like I can change this. There's an MR, it should still recognize that as MR. Okay, lumbar. It knows that's lower back. Let's give it a little more a clue. Okay, it's lumbar spine. And then there are lots of ways to say without contrast. You should just be able to do that. And there, it's resolved to that concept of clinical imaging without contrast, or you can actually just spell out without contrast, etc. So yeah, 3 layers of unification. And with that, I'm going to switch gears, and I'm going to show you. Everything that I just showed you up to this point is it's live and in production clinical use. And now I'm going to move on to some advanced AI functionalities that we've been developing. And give me just a minute here. Unsave. Let's do a draft. Okay. All right. So now I will introduce you to our AI sandbox, aka the Rhino agent. This system, under development but fully integrated into our platform, has access to all relevant patient context and many functions and tools. And there are 2 ways to think about it. One, you can think of it as like a real-time AI co-pilot that you're interacting with in the course of doing a read. And the other is as an async automation platform, which allows for flexible workflow templating that can happen at any time, like not just while you're reading, but at ingestion or when you open a case or at set times. So what I'm about to show you it was a big hit at RSNA, but I think it's not that we didn't architect it in an interesting way, but the real power of it comes from the from our unified system, and it just has a huge surface area to act upon, and so it's more powerful as a result. So what is this thing, and what can we do with it? One level, it's just a chatbot. Well, you can think of it as a chatbot to begin with, and we'll build upon that. You can select what model you want to talk with, and you can just have a conversation. Now, the thing is, we've added, and it remembers the conversations. You can go back to them for each patient. So we've added a layer on top of the base chatbot, this agentic layer. It basically has this orchestrator agent that is listening. And the first thing it does is determine, like, do you want to talk with it or do you want it to do something? And so I'm just going to talk with it for now. Hi. And hopefully it just replies instead of doing, oh, here it is. Look how friendly it is. And it's capable of doing a bunch of different things. We architected this. We had about 25 different use cases in mind. And it can do all of those to varying levels of accuracy. There are ways to make it more performant, but then it's capable of things that we never even thought of. But so let's test it out. I don't just want to talk. I want you to do something now. So how about this? Here we have some AI outputs, and this is just one AI output, but I think we can imagine a future where there are many AI outputs for an exam. And how do you actually go through and look at everything? And do you want to like redictate into the report, or is there a way to just summarize everything and get it into the report? And I think there is. Tell me if there's anything interesting in the AI outputs in the DICOM and update the report if so. And so it should realize that I am asking it to do something instead of just talking, and it did. And now it has a number of different tools available to it and skills. And so, interesting. Okay, so it pulled all the information. Again, the power of unification. We have the DICOM, we have the reporter, we have this AI agent. And so it read this information, and it understood that I wanted it to update the report. So it planned its edits and applied the edits, and here it is. And so, voila. Let me show you another interesting example. How about this one here? Let's discard that. Okay, now here we have an ultrasound, and this is just really interesting to show you the power of this thing. Again, the power of this unified system. I'm going to ask it to import information from the tech worksheet into the report and analyze the hand-drawn images and comment on the arterial plaque. So let's see what it does here. Great. I mean, the first thing it does, it comes up with like a to-do list. So I asked it to do a couple things, and it's loading an ability. So we have tools, which are like, I don't know, fetch PDFs is a tool, and then there are abilities, which are these configurable workflows. It could probably figure out how to pull stuff from a tech worksheet by itself, but we've built effectively an automation so that it does it in the way that we want. So when I asked it to do that, it knew that it should load that ability. It's using its PDF tool to actually process the documents. And let's see where it is. Okay, great. Huh. Okay, now it's going to update the report. The really interesting thing is, let's see how it does here. And by the way, this, as part of defining these abilities, these automations, you can tell it what model you want it to use, because certain models are better at certain things than other ones. And in this case, we're using Claude Sonnet to do. It's the orchestrator, and I think it's also the one that's being used for the OCR, although I'd have to dig in to see exactly what is happening there. But you can point it to any model to do any particular thing, and that includes pointing it to diagnostic models. So if you wanted to like generate a draft report, you would just set up a skill ability that way and point it to whatever you want, Hopper or whatever diagnostic algorithm you want. And so anyway, so it did the thing. It ported all the information into the worksheet. And by the way, this is something we're working on now that's just going to happen in ingestion, so this will all happen automatically. And then did it actually look? Yeah, so it saw the image, and this is its interpretation. I'm not sure exactly how correct it is. But yeah, there is an example of the power of unification and making the most of AI. Thank you. Thank you, Other Mark. I hope you guys enjoyed that.
So, thank you, Mark, Dr. Longo. It's really powerful. Dr. Kagan, I don't know if you want to have a little discussion with Mark a little bit, as we recently showed you this technology, kind of what was your impression of this, and how impactful do you think this is, and where do you see this going?
Well, I love seeing that, and always love chatting with Mark, but especially about this because as we talked about earlier, with the volume of cases and the complexity and cognitive load needed to really focus on the sickest patients and the most complex patients, be transcribing numbers from one image into a report is something that we shouldn't be doing. It's not practicing at the top of our license. So having agentic workflows to do that for us is one example. And we're all in for that kind of workflow. We have radiologists who are working on that, for bone density and other ultrasound measurements. So this now scales it and allows access for all radiologists to use it. So I think those examples particularly are especially where we need to go. And focusing on consistency and flexibility for a radiologist, being able to read wherever they want. As Curt mentioned earlier, the market is very challenging for hospitals right now because radiologists have so much choice and there's so much volume to read. So allowing flexibility for radiologists, whether they're on-site, hybrid, or remote, is huge. Lowering our operational and IT burden so that those rad IT colleagues that we do have can really focus on helping us in the reading room and not on just integrations. And something you mentioned, Mark, is being able to choose which language model you want, is incredible. So you can, there, as we know, there's certain agentic workflows that may be served better by some language models versus others. And especially in centers like ours, where we have engaged very intelligent and smart colleagues in like our Department of AI, who will build for us some use case models to be able to integrate those into a platform would be wonderful for us. And we may have use cases that Stanford doesn't have. So we may want to have specific workflows that agentic AI we can deploy on, and allows us to be both buyers. As Curt mentioned, we dominate the market, and if you add cardiology to our radiology list, we're probably at over 80% of all the FDA approvals, because it's really a lot of the cardiology approvals are imaging related. So it allows us to build what we want with the small teams that we have, and buy AI models and deploy them on one platform. So I think that gives us freedom and adaptability, especially as we all know, these models are evolving over time, and there may be open source models that come to fruition in the future. I just heard about a new one that that people are using. So anyway, I think it's empowering us to be able to choose between those. Anything to add there, Mark?
I would add one thing. This is when we add a model like this, even if it's just a simple OCR model, it's a refresh button, and every single one of our customer gets it. So this isn't us going out to 3,000 different PAC systems and updating them on a function. It's the power of a unified approach. So, if somebody wanted to go ahead and implement River Rain, or Harrison's AI may do some work down in the future, our ability to integrate with that and then have everybody have the ability to use it without having to do any upgrades on their software is really where innovation happens. I mean, it really comes down to what Curt was talking about in the very beginning, which is if you can't deliver it to the radiologist, then there's not tremendous value.
Yeah, and I would add, my reaction to Mark's demo is just the power of tools, that if you put in the hands of an AI agent, multiple tools, it can do a lot of good for you as a radiologist, save you a lot of time. But just think for a minute the complexity. If you have various different vendors, you have a reporting vendor, you have a PACS vendor, you have a work list vendor, and you need to have that relationship, that tool relationship. I need to grab stuff from the report. I need to insert things into the report. Just the complexity of those business arrangements compared to having a unified system, I think argues for this kind of a platform. The other thing I would say is I think the future of this is sure, there will be some radiologists who want to go to the chatbot and do all kinds of really interesting and wonderful things. But the other thing that'll happen is a kind of zero touch approach where, oh, the AI knows, oh, I see, this is this kind of a study. It has the PDF thing that I've got to go in and grab the data and put it in the report, and it knows what to do. So you as a radiologist, you don't have to chat with anything. It just shows up in the way that you want it to show up, zero touch.
Those are all really good points. And yeah, I think the automation aspect, I presented it as a AI co-pilot, but also you can just set up automations to offload so much work. And the configurability of it, and it's relatively even easy as it exists now to configure these workflows and just point to a different model and you're using a different algorithm, doing a different workflow. It's been really fun to work with our advisors and our customers to figure out where to take this stuff. It just feels like imagination is the limit, you know.
So in the last couple minutes here, I'd love to pull some questions in the chat. And while we are doing that, if we can go around maybe and do sort of a takeaway point from each person of the panel, from your seat, sort of what's the most important takeaway or impact of the session today, and what you're excited about going forward. And for those of you listening, please feel free to drop some questions into the chat. Maybe Mark, you're front and center on my screen if you want to start.
Oh, sorry. What I was reading the comments. What am I
Just
starting?
a rapid round of sort of what's most important from your seat today in the space and context of where we are.
Yeah, I mean, maybe just briefly, I'll say I think AI succeeds or fails based on the platform beneath it, and that's what gives it the power, and it's just up to us to decide where we want to take it.
Yeah, this is Ken. I would add, having sitting in thousands of reading rooms, the ability to go ahead and do what Mark talked about, but with the way Curt suggested, which is pre-processing, where the AI knows what to do with it with a study, is really, I think, going to be revolutionary for radiologists. So, don't even ask for it, just have it done. So when it comes time for reading an ultrasound, or if it comes time for reading a study that had some AI algorithm run against it, that automatically pre-put that report into the report and have the radiologists are just ready. I think that's just a huge advantage for the future. And it's probably the first time we really thought about the radiologist. The last 20 years has been, kind of about how do we handle all this large data? But this is slightly something, this is really different in my mind. It's really helping the radiologists in terms of reducing the amount of workflow and increasing efficacy. And as we said, a radiologist transporting numbers from an image into a report is really not the best use of that time.
Yeah, and Andrew, maybe I can take a couple of these questions before I give my takeaway. This issue of standardizing exam descriptions in HL7, all of that. There is some interesting work that's been done, something called the RSNA Radiology Playbook, which are standard exam names. They're now a part of LOINC, which is a terminology that's used for imaging orders and results. But you're right, even with that, what we really need, I think, what would really accelerate radiologist workflow is standard names for the series, because then algorithms that try to automate display protocols can key off of those series rather than have it be a kind of Tower of Babel with multiple names. There's work going on with that, but it's still at an early stage. But I'll say that's another area where AI can help. So there's this notion of helper AI, which can look at the pixels and say, well, what is this, a T1 weighted image or is it a T2 weighted image? So, again, this kind of agentic approach that Mark showed can be really powerful to help solve some of those problems.
I'd love to jump in, Kurt, and
Yeah,
add
go ahead.
one question about, the AWS, and I do hear it about, all the time. Like you're going to the cloud, and there has been some news about failure in the cloud, and what does that mean to your business, and is that at risk? And for somebody who's managed thousands of PAC systems from a management standpoint, just to give you an idea, if you're in multiple zones on Azure or AWS, you're traditionally getting 11 nines worth of reliability. And from somebody who's lived it, because if you have a thousand customers, even in the best circumstance, if you have a 10-year-old RAID system, you have 2 to 3 nines of reliability. So I understand that people are worried about the cloud, but really what's the ticking time bomb is the average radiology system that's on-prem has sometimes 20-year-old disk storage, and that failure rate, when that goes down, that takes days to reassemble. So I'm not saying that the cloud is perfect, but I'd rather have 11 nines than 3 nines. I don't know, Kurt, if you'd want to expand on that, but
Well, I would just say, I just experientially, just think to yourself, how many times have you read a story about the cloud going down over the past year? By the way, there are three clouds, okay, major cloud vendors, versus the number of times you've heard that your PAX is down. So, it's a difference. And in fact, you know, if you think about the cloud vendors over the last, I would say cloud 15 years ago, yeah, there might have been a reliability problem. But cloud over the last 15 years, they have experience now serving the US intelligence community, a lot of vendors who are customers who have uptime needs that are the same or even greater than ours. And so they, as Ken described, they have all of these tricks and tools that give extremely high reliability. So I think it's actually, if you do a head-to-head comparison, I think you'd find that the cloud tools have far greater reliability.
And I'll just add, Ken mentioned nines, and everyone on this call is familiar with nines and reliability. But I'm proud that yes, we did develop some point triage solutions, but also this unified platform. And really, the unified platform and unified workflow is how we're going to adopt agentic workflows and rapidly changing AI, because it almost feels like it changes every week. And so being able to adapt and adopt the best workflows, you have to be able to do that. And so, having a unified cloud platform seems like the best way to do that.
And maybe, Andrew, real quick, I'll address this question about EMR scraping, which I think is a really good one. Yes, there are really two different modes of AI that you need to think about as a radiologist. If you have an AI, let's say, that's drafting a report for you, you've looked at the images, you're looking at the report, you're capable of telling whether that report is accurate or inaccurate. So you are, in fact, the human in the loop monitoring that AI and making sure that it's accurate before you sign that report. When you have a summarization tool, now you do need to think about, okay, when it tells me that something is true about this patient's medical record, maybe I should validate that. Like, it's good that it brought that to my attention. And so many of these summarization systems you'll see will have a little link you can click and actually go back into the record, and it'll show you the exact data point that it's using to create that summary. So those kinds of explainability, trustability, validation features, I think, are very important when you get to that kind of an AI.
And just like how I would thumbs up this comment, I see I'm able to do that. You can do the same in our EMR vendor. With those AI summaries, you can actually give feedback, to the EMR vendor that this AI summary, was good or it wasn't. But yeah, we really do like it. We use it. But also being able to summarize, our reports would be critical too.
Awesome. Well, perfect timing. Exactly an hour. Thank you, everybody, so much for joining us this afternoon. or morning, depending on where you are in the country or world. We will be following up with some content summary video of the recording of this session as well. But just wanted to thank everybody for joining. And if you have any questions, please don't hesitate to reach out. And thank you so much.
Thank you.